Hey guys, welcome to Unit 8, Lesson 2 on Power. Alright, today, like I said, we're talking about power. The definition of power is the amount of work done in a certain amount of time. It's basically the rate at which work is done. Anytime time is in the formula or in the definition, it is considered to be a rate. The formula for power is work divided by time, or P equals W divided by T. If you want to use the triangle, make sure you put W on the top, P and T on the bottom. A unit of power is called a watt, and 1 watt is the same thing as 1 joule per second. Because the formula for power is work divided by time, work is measured in joules, time is measured in seconds, so 1 watt, or 1 unit of power, is joule per second. People performing the same task do the same amount of work, but the person who does it the fastest uses the most power. The best example I can come up with for this is the swimmer Michael Phelps. He's won so many Olympic medals for swimming, but you could probably swim a lap. If you swim all the way down and all the way back, Michael Phelps would swim all the way down and all the way back. You would have done the same amount of work, but since he beat you so badly and his time was way better, he used the most power because he got the same amount of work done in less time. We also did a lab about this whenever we ran up and down the stairs and we walked up and down the stairs. Each time we did the same amount of work, but whenever we ran, we got the work done faster, so we used more power. Power is also called the rate at which work is done. Like I said, it's a rate. A rate is anything divided by time. Let's try a practice problem. Miss Weems lifts a 1250 Newton barbell 2 meters in 3 seconds. How much power was used? For this problem, we have to find the work first, and then we plug the work that we find into the formula for power and divide it by time to see the rate at which work is done. Pause this video for a second, take a chance, and try to work this one on your own. Here's the formulas. The power formula, power equals work divided by time. But first you have to solve for work. You have to divide force by distance. The red one. Okay, what you're going to do is you're going to solve for work first. You do 1250 newtons times 2 meters to find the work, which is 2500 joules. And then you take the work and you divide it by time to find the power. So if you did 2500 joules of work in 3 seconds, that's 833 watts. Remember, watt is the same thing as a joule per second. And another practice problem. If Miss Weems weighs 700 newtons, which again, I don't, and generates 800 watts of power climbing a 6-meter ladder, how long would it take her to reach the top? We have to work backwards on this one as well. This one, it's looking for how long would it take, and that's going to be time. First thing we need to do is we need to find work, and then we need to use the power formula to solve for time. Pause this and try to do that on your own. Here are the 2 formulas you're going to need. And here's how you do the calculation. To do the work, you find 700 newtons times 6 meters is 4200 joules. Then you solve for T using the power formula. You get time equals work divided by power. We found that work was 4200 joules and the power was 800 watts. And time was 5.25 seconds. So it took 5.25 seconds to climb that ladder. Today we talked about power, and that's all.